Hello, everyone, and welcome to our webinar today. We have, I hope, three interesting presentations that will talk to you or present to you some of the special features of the Stella software, which most of us use, but not all of us use, um, in just bringing the attention for instructional purposes. My name is Diana Fisher. And I am the first presenter. I was a high school math teacher for many, many years, and I used system dynamics in teaching mathematics at the high school level for 20 years. Um, I am going to talk today about one of the newer features that occurs in all Stella products, including the free Stella Online. And I'm going to actually show you, I'm going to work in Stella Online so you understand that you can practice this if you're interested right away. Okay, so loops that matter is what I'm going to talk about. And the purpose of talking about this is to show you a little bit about this feature in the software. And also, um, the purpose is to help students explain the dynamics of a model better using feedback and loop dominance. Okay. The agenda, well, I'll show you where to locate Stella Online in case you don't already know. I'm going to give you an example of a basic epidemic model. I am not going to show you how I constructed it. It is a fairly well-known model. I am going to work on that model. I'm going to show you how to turn the feature on, how it helps you identify the feedback loops, the type of feedback loops each one is, what percent of model behavior is defined by each loop, and identify where transfer of loop dominance occurs, and creating a and the loop dominance feature also will translate the stock flow diagram into a causal loop diagram, and I'll show you that quickly. Then I'm going to expand it a little bit because I'm going to add a recovered population to the model because the graph to identify loop dominance is more complicated, and I wanted to show you. In the first example, it's very easy. In the second example, it's a little bit more complicated, so I wanted to show you that. If you don't know where to get Stella Online, take a snapshot here, and this tells you how to find the software. This is what the modeling window looks like, and this is the place where you turn on and off the feature loops that matter. Um, that's where you turn it on and off in the software. This is the model that I will be working with, the basic epidemic model with just a susceptible and infected population. The infected population is increasing over time, and the susceptible population is decreasing over time as the susceptible people become ill. And this is the typical graph of the behavior for this particular model. Okay, so now I'm going to stop this sharing and go straight into Stella Online. So this is can you all see this pretty well? Can you see this?
Yes.
Okay. This is the model that I showed you. There's the calculate loop dominance that is turned off right now. And I have increased the sim speed, actually increasing the seconds slows it down. So I made it 10 instead of the default 0 because I wanted things not to happen quite so quickly. So here is the standard behavior of the model. And then I am going to double click on a blank space here to bring up the model settings panel and turn on calculate loop dominance. And I am going to click to run this again. And I don't know why it doesn't show what I want it to show right now. I'm going to have to click this twice for you to actually see what I want you to see. So you can see these links that are red and blue. And the links themselves, if they are red, it's a change in the same direction type of link. Normally, we identify it with a positive, a plus symbol link polarity. And I'm assuming that you know about link polarity and loop polarity, and you have some background in this kind of modeling because I don't have time to explain all those details. This is thick because it's a very strong link at this ending point. Blue is an opposite polarity. It's the destination increases if the source increases, the source variable increases, the destination variable decreases. It changes in the opposite direction. I don't find these loops, these links very helpful, so I don't analyze that particular part of the loops that matter. I don't use that particular part of the loops that matter. As a matter of fact, I think I'll turn that off. What I'm really interested in here is I'm going to undo this. What I'm going to do down here, I'm going to increase my screen size so you can see this table down here, which is very important right now. Oops, a little less than that. Okay. So what we can do here is there are two loops in this model. There is a reinforcing feedback loop called R1, and there is a balancing feedback loop called B1. And if you want to see where those loops are, you go over to the flashlight at the end of the row and you click on the flashlight, and it will show you in your stock flow model where that feedback loop is. This is the reinforcing feedback. More infected means more contacts, which means more contacts with susceptible, which means they're becoming infected, and it increases the infected population. Clicking the balancing shows you this is a balancing loop here. More susceptible means it's a higher probability of the total population, but it means they have more contacts with infected, so more become infected, which reduces the susceptible population. Okay, and I want you to notice something else. On the original model, I did not put polarity on each of these links. When you run the loops that matter feature, it puts the correct polarity on each of your links. So I want to click now on both of the loops at the same time, and I want you to see here this table. And it's really actually, I don't want you to look at the graph right now. Sorry, I skipped over something here. I want you to continue to look at the table down here. In the total column, it tells you of all the behavior that is expressed during the entire run, 90% of the behavior can be explained by the balancing feedback loop, and about 10% of the behavior can be explained by the reinforcing loop. That's what the total means. The current is at individual points in the simulation. So if I go back in time, notice the time here on the right-hand side of this bottom designator at the bottom of the screen. As I move it to the right, I want you to notice that I am at time 3.25 days, and the reinforcing feedback is almost 99% controlling behavior of the model product right now, behavior, and only 1% of the balancing loop is controlling behavior. As we move across, you will see the numbers in the current column change based on the time of the simulation run. So that shows you over time which loop is dominant at a particular time, whereas the total tells you for the entire run which one was producing more of the behavior. Now let's take a look at this graph. You can get the same behavior up here. If you click and drag, it shows you at every time unit what percent of the behavior of the model is being controlled by the particular loops. R1, the red is the reinforcing loop, B1 is the blue loop. And what we want to do is find out right now, 98% of the behavior is dominated by the reinforcing loop. As I move to the right, that is becoming less and less dominant. But it's still dominant until it's under 50%. So right now, you can see that the balancing loop is 50.4% and the reinforcing loop is 49.6%. And that's the transfer of loop dominance. The transfer of loop dominance occurs at time 8 days. And that's what you want to know. So for your students, and this was something that Billy Schoenberg created this feature of Stella. And he's also a professor who's taught students at University of Bergen. And they have done a lot of testing with the students to see just how best to get them to improve their explanations of dynamic behavior. So what they said is in the software, you should first have the students, let me see if I can get this to move down. I figured I wouldn't have time to write, so I did this in advance. First, you should have the students identify each of the loops with the explanation of the loop, which I have done here. And it's just the words of what I said when I began this presentation. The reinforcing, you should give it a name as well. Spreading infections for the reinforcing loop, because that's what that loop is doing. Kind of the number of healthy people is what the balancing loop is keeping track of. And they should do that first in the software, they said, because even doing that on a separate piece of paper, something gets lost a little bit. So you want them to do it in the software. Then you want them to use the graph to identify where the transfer of loop dominance occurs. And what they say is loop dominance progression should be identified as from time something to time something else. So from time 1 to time 8 days, R1 was spreading infections, was the dominant loop behavior that controlled the behavior of the model, of the output of the model. But from time 8 to time 80, which is 80 days, B1 was dominant. And then what they do is you ask them to write an explanation explaining the graphical behavior using this information. And I think it's really important for students to use just this little bit, putting it together to make sure that they have what they need to give good explanations. The one last thing I want to show for this example is that up here in this next to the execute magnifying glass is a little flow symbol. If you click on that, this gives you a causal loop diagram of the stock flow model, and you can click on it again to go back. So if you're interested in that, it will show you a causal loop diagram. Now, I want to quickly go to the other one. I think I have 2 minutes left. This is the same model, only I have add recovered population. And here I have I have another feedback. So I want to turn on calculate loop dominance. I want to run this, and the model behavior is different. You can see that it's different. And so I want to open this up a little bit here. And you will see we have three loops now. We have the reinforcing loop that we had before, which was at the beginning, the infecting loop. We have actually the number of susceptible is loop 2. It just chose that as loop 2. And the balancing loop 1 is the well, I can show you. Let me move this over a little bit. And I can show you that using the flashlight, you can see the reinforcing loop. Using the B2, that's the balancing loop, and B1 is the new loop that has been put in. So let me highlight all of these and find the loop dominance. So you need to be more than 50%. And so here, the first time that our reinforcing loop loses its dominance is at, I think, 8.75 days. So we would write down that number, 8.75 days, R1 is dominant. And it looks like B2, I'm at 8.75 days, and going forward, B2 is dominant because it's got 95% of the behavior description. And you keep going, and B2 is 66, 69, 71. Looks like B2 is still pretty dominant, but right here, B2 is no longer dominant. R1 is not dominant. B1 is not dominant. So in that situation, you start with the loop that has the most percentage, and in that case, it's B1, and you add other loops of the same type. So what is dominant now, starting at time 13.625, is B1 plus B2. They are dominant. And let's go a little bit further. Okay, well, it's not quite. Okay, here, a little bit further, time 13.875. Now, B1 is totally dominate. That's the reinforcing, that's the loop, the balancing loop for the recovering. That has 55%. And so it's now the dominance is B1, and that is for the rest of the time. So if we take a look at the description here, I have to move this over. If we take a look at the description, I'm going to move this up. You will see that I have explained three of the three feedback loops here and given them each a name. And down here, the loop dominance, I identified as I was talking about it, that at the beginning, R1 is dominant, then just B2 is dominant, and then B2 plus B1 is dominant, and at the end, just B1 is dominant. So my time is up, and I'm going to stop here, but I have shown you how to use some of the basic features of loops that matter to help make the explanation of the behavior of a model more rich, okay, more complete, using the feedback and loop dominance transfers. Okay, so we do all presentations first and questions at the end. So I would like to, what you're going to see in the next presentations are going to be a lot of fun. I'm going to give it to Emre to talk about some exciting things that you can do with the interface layer of Stella. Thank you.
Okay, thank you, Diana. Uh, Let me share my screen first. Yes. Uh, so before I start the presentations, this presentation, I want to make a disclaimer that this presentation will not cover all the features of this interface. That's because I learned all of this by trying to develop interfaces that the teachers prefer to use. So this won't be a presentation that covers all the features, but we'll probably cover the most demanded ones. For the presentation, I want to use this Miro board. It's an online board. It's a very large workspace. You can zoom in and out. The link for this board will be posted on pre-college special interest group webpage along with the recording after the presentation. So this, what you see here, is a visual of the blank page from the interface of Stella Architect. By the way, Stella Architect, this feature, the interface layer, is in the paid versions of Stella, namely Stella Architect and Stella Designer. I'm currently using Stella Architect. So in this page, these are the page elements that you can use to build an interface. Some of these elements are in, like here, red rectangle lines, connect them to these interfaces that I use that element. The one with different color is this one, the green one. It is called model view. This has a different color because I always use this page element because all my effort is to show the structure. And this element does this. It gives a snapshot of the model and behind the model. So for the full screen, I'm trying to present these 10 interfaces that I chose to present in less than, hopefully, 15 minutes. Let's start with the first one. Actually, in Miro, you can just embed web pages, but instead of using this one, you can also open the page in a different tab. This will increase the visibility. So these interfaces are all web pages and they are open. They can be reached through Exchange, IC Systems Exchange. So the first one is some examples of loose with two elements. These are actually flashcards designed for a university course for pre-service teachers. Each card have two elements, uh, and the instructor chooses a card and asks the student about the interrelation between these two elements. And after some discussions, success and motivation, for example, it just opens and shows what is behind uh, these cards. Uh, this feature or this animation is done by changing the visibility of two elements. There's a box here and another one that hides the causal loop diagram, that simple diagram. And these two page elements, pieces, are their visibility is linked to a button, and when you open and close that button, you just change the visibility of it. And this is for a general purpose usage, and this is for sustainability. Actually, the course was about sustainability, and these were much more used. And Another example is for the third graders. This is about Mediterranean seals. It was a project about this threatened species. The threat is, of course, humans. So this project aimed to raise awareness about this issue. A similar, very similar mechanism is used in the interface, but this time instead of buttons, some threshold value of stack is used to control. This is the stack, one stack, uh, and these are the buttons running the model. When you run the model, various causes of increases in stock appears. This slider, this one, is used for discussing each cause, starting with the fisheries, and then something happens, tourists comes, your, here is the, and, and after some time. These are all causes that threatens this species. Uh, but I need to warn about this model. This model seems simple, but at least for a third grader, it is not so because the causes on the flow side are decreasing the flow. So although the flow is an inflow, this is an example of how a decrease in inflow can decrease the stock. This behavior can be confusing for both teachers and students, so I do not recommend it for the early stages of introducing stock flow diagrams. Uh, Another example is how do flows change stocks. Uh, this is the interface designed for the same university course for pre-service teachers. After seeing that the service teachers had difficulty with various effects on flows on stock, this is a very similar in design. We have flows and the graphs of them here, and the stock is to be estimated. Uh, and while you can open and changing the visibility of the stock, you can see what will be the behavior of the stock is. And we have these two, again, two buttons. And by these buttons, these sliders are unhidden or shown. And you can, for example, I can do this and see, actually, this was the way to do it. And we can think or discuss what will be the behavior. And after this, we can do this and discuss a little bit more. And you can see what will be the behavior or not. And we have one more button here, the show graph or area between the flows. This is important because when I click this, again, another graph is hidden and another one is shown. This is the one that shows, this is a area graph. And these areas, the green one is that increase, but increase is decreasing, that here. And then decrease starts and it uh, gradually increases. And you can see this behavior in an area format here. Uh, and this is however you wish to work on it. Another, uh, oops, hmm, can, well, I should be, hmm, let me reload this. The first three examples use control elements that mainly change the visibility of elements on the page. But hmm, okay. Uh, The following ones will use an SVG file. SVG stands for Scalable Vector Graphics. It's an image format like JPEG or PNG for two-dimensional graphics. The difference is that SVG files support interactivity and animation, so you can access the object in the image. So this will be an example for uh, sustainability. Well, this is for fourth graders. It has been implemented in two IB schools, one in Turkey and the other one in Canada. When you run this, it gives a behavior over time graph of the observed values of the depth of Aral Lake between 1960 and 2017. There is no animation here. The challenge for the students is to find the two values of the model here, the outflow and the initial value, to produce a similar behavior. Of course, I know the answers. And when you 50. So when you give the numbers, as these all animation depends on the depth value of the stock, some animation happens. One is we have that blue area here. When I move this, I can see it is going down like a bathtub. And another one is when there is something to evaporate. This is a GIF file actually. This works. This is from hidden to shown. Its visibility value from 0 to 1, and we can kind of animate this behavior. And an example from high school chemistry. This is for ninth graders. Uh, this also have a similar structure. Uh, First, but this is a little bit different because the size of object is uh, proportional to the energy change here. When you run the simulation, the hidden some parts are hidden and then shown again and then again. We can see here, for example, there is an ice cube here, and oops, let me run again. That ice cube becomes solid water, liquid water, and then it should work. Yes. Oh, I think I reset when I do that. So this is the time, the temperature stays the same and then going up. You can see it here. And so we have all kind of stimuli to visual, mostly visual, of course, but different shapes and graphs, and also they can try this one. And another uh, interface is about ninth grade geography class. The topic is atmospheric circulations. Uh, Actually, this model is where the underlying structure, the model is least exposed, and but the teacher was happy with it, so I go. So this is the model, altitude, latitude, and an array of these stocks. It is very simple and does not give much insight about the behavior. But this might, for example, this kind of a, animation uh, seem to help students understand the topic because this is more realistic, and this is the effect that these clouds do not land just some 100 kilometers just north of where they were formed. They just go to south, to east, not south. So another example is from math, and this is for second graders. Well, I have to reload this. There should be somehow. It's about transactions in a greengrocers. Uh, Apples are bought and sold and create some various flows. When you run this model, you can see what's been done. But this should be done with an agent-based modeling because there are 33 apples and 150 money icons, and they all have to be tracked down with arrays. And uh, well, it was an experiment to see if it could be done or not. It can be done, but it is undiscussable if it is worth it or not. Another, I can't. Hmm, last three, and this one is from physics. The rest of the three interfaces. Uh, this is fifth grade, and there are six questions, but I want to show the sixth one. We put some fields here, and between the fields, we put a text. And you can give some numbers on these texts, and for example, three, 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 three. So, so the story becomes a turtle starts moving at 3 meters per second. After 3 seconds, it gets tired and stops rest. Units are not very logical, but after resting 3 seconds, and uh, first, this can be discussed or this might be given as a problem. And when you run this, uh, it can just do what's being given here. So this is another SVG file and using some fields to be used as stocks and flows or starting points or any some kind of usage in the model. Uh, Another one is about this time it's for high school physics, and actually this is uses the basics of the previous one. We have here one stock position and the speed, and here this is the position and change of position, and we put change of position is velocity and change of velocity is acceleration, and acceleration is a result of mass and gravitational force. And when you and the position is linked to the position of the ball on the screen. And when you run this, you have all the energy transformation and some other graphs. And if you do this as a projectile, all you need to do is this is the vertical position and velocity. All you need to put is, let me restore here, horizontal position and velocity. So we have two uh, dimensions. And when you run this, uh, it does according to these relations. And you can change, of course, these relations with sliders and get different behaviors. And we have this pendulum, but without a string. So it was very hard to do to put the string there. So I just put this one. Uh, and another one, the same principles is can be used for sun, the movement of sun, earth, and moon. Uh, the initial numbers are I got from I think from either Wikipedia or NASA, but they are all the weights, the distance of the bodies, And when you run this, with all this initial positional or weight and distance information, uh, students see that the Earth really tours around the sun in 365 days. But with this initial conditions, so changing these initial conditions to create longer or shorter years can be a task for the students. And the same is uh, for the moon, but it is, of course, much more faster as we have uh, more than 12 months. So this was the last interface example, and thank you for your patience.
Thank you very much, Emre. Steve, why don't you go ahead?
Okay, I'm going to just dive right in because we're running a little short on time. But I am first of all, let me share my screen to make sure you can see what I'm doing. Okay. All right. So I'm going to thank you, Emre, because you demonstrated all of these amazing possibilities of what is possible to do with the interface on Stella. And I'm just going to look into one piece of that, which you didn't look at, which is called storytelling. And storytelling comes out of the interface window as well, which is where Emre was doing all of his work. So um, essentially what storytelling is, it's a feature that's available in Stella Architect and in Stella Designer. Most schools don't have this available for student use. Possible after you've created one of the models that have to publish it to the isee exchange, and then it becomes available to anyone who has exchange account. I've also used storytelling as a way to encourage discussion in a classroom with a projector at the front of the room and kind of work your way through a model one step at a time and discuss the pieces as you go along. So to begin a story, it's best to have a fully built and a functioning model. And so for this demonstration, you a model, a predator-prey model that was developed by the creative learners. I've modified it a little bit to make it a little simpler on the screen, but this was something that they put together for their Waves of Change curriculum. So here's the model, and just to let you know what it looks like when you run it, you see you got this oscillating behavior. I have the loops that matter turned on here, but you can see we have this oscillating behavior between the predators and what I would like to do, and again, this is just going to be scratching the surface of what's possible here. But what I'd like to do is show how by kind of increasing the complexity of the model one step at a time or one loop at a time, it's possible to see how the behavior will change as you do. So each of these substructures become a very important part of the model and the model's behavior. So I've got the model here. I'm going to reset it so that we don't run into any problems later. And I'm going to move over to the interface window, which I think Emre had showed you. I hope you can see this. Is this big enough on the screen for people to see?
Yes.
There's an icon here that looks like a monitor with a little triangle base underneath it. If I click on that, it will open up the interface window. And typically you might get a window here that would just say, do you want a template? I've just taken the first page of the Creative Learning Exchange, excuse me, their interface to use as a basis for this, because you need to start from a home page. So over here on the left-hand side, there's a label here, context, and there's a drop-down menu or pull-down menu, and you can see I can add a new story. So I'm going to go to that, and I will add a story here. I'm going to name the story. I don't know, for the sake of something better, adding new loop, we'll call it. I'm going to call it that, and I'll hit OK. And I get a window that's asking me, what do I want these pages to look like? And rather than put any kind of template on it. I'm just going to make a blank page. So this is the first page of my story that I'm trying to create here. And when I open this up, what I will see is the entire model that's underneath all of this. And I'm being asked here to choose which pieces of that structure I want to include on this first page of the model. So my interest right now is in the initial reinforcing loop that causes prey to grow exponentially, right? So on loop. So I'll click on prey, on the flow of births going into it, and on the connectors, as well as the prey births factor. And I put labels for include a label, which I've included R1. And if I hit OK, you see what turns up on my page is just that model. Okay, and at this point, you can think of this page as being just a typical interface page. I can put things on here. I can put buttons on here. I can put a graph on here, text, all kinds of different things. So because I'm interested primarily in the behavior, I'm going to start by putting a graph. So I'll put down a graph here, and I want that graph to be a graph of prey. So I'm assuming people have used this a little bit, but I'm choosing prey here as what will be graphed over time. And I might want to put a little bit, well, first of all, let me show you something that's really, really interesting about this. I'm going to go back underneath to the main model, and I'm going to hit run. And when I do that, if I go back to my interface, I'm getting the oscillation, which is not what this is, right? I mean, this be look at the of this part of the model, I should not be getting an oscillation. That's because in the storytelling mode, you can actually get partial simulations of a model, but only if you run the model from the page. So I need to create a way to run this model, this kind of mini model here from the page in order to get the proper behavior. So to do that, I can put down a button. I'll put it down here in the lower right-hand corner. If I double click on that button, I get a window that allows me to put a label on it. So I'm going to call it run. And I choose here from a list. I'm going to hit the plus sign. Whoops, I'm sorry, take that back. I'm going to down here at the type, I'm going to select the action for that particular button. And you can see there's a lot of different actions here that you could choose, but I just want to run the model. So I'm going to choose run. Sorry about this. And come back to here. And now I have a run button. I've got a graph, and I have the mini model. To see how this works, if it's working the way it should, I want to go up here to the toolbar at the top and click on experiment mode. And I can see now what my first page of the storytelling story will look like. So if I hit run, you can see I get my exponential growth curve. Okay, now it's probably important to put some context on this. So I'm going to add some text. And you may want to put more than this if you were doing this for students, but I'll say something like without constraints, prey population will grow exponentially due to a reinforcing feedback loop. Okay, so I can add that text. It's probably also important to put some instructions down, because in a story, when you tell the story, you have to press the space bar to move through the story. So I'm going to add what's called an annotation button, which is up here in the corner. I'll click on that, put this down here, and I can put my message here. Double click on that, and I will say to move through the story, click on the space bar. And maybe I would add to hide this message, click anywhere. on the page. Okay, so that's the message. And I would like that message to be visible all the time. You can see I have a checkbox here, this hide button. I want to, it looks like my internet's unstable, so I hope this holds up. And let's go. Button options. I want to put the label here. I'll put instructions for the label on my button, and I'll hit OK. Okay, and let's put this somewhere down here in the middle. And go back up here to the mode, and now I have this. If I click on instructions, the instructions will come up. I click or else it will go away. If I run, I still get this. And I think it's probably important as well to put another button just to restore the model. So I'm going to click there, and I'm going to have this restore all devices, and we'll label it reset the model, something like that. And make this big enough so you can see it. Okay, so here it is, page 1. Hooray, we've finished page 1. You can see I can look at the instructions. I can get rid of that. I can reset the model. I can run the model, so on and so forth. So that's page 1. Page 2, what I would like to do now is I'd like to kind of unfurl this section of the model. This is a balancing loop that will put a limit on the growth. So I'm going to do this one page at a time. So you wouldn't have to do this, but I think it's an interesting way to approach this. So we know that the prey, if it increases, it will increase the prey density, right? So I'm going to click on all of those to select them. Make sure I have them selected. If I hit OK, you can now see on this page, I've added one piece. And I might want to put a little bit of context here as a text to say something like increased prey leads to increased prey density. You know, and you might want to include a decrease in prey, which leads to decreased prey density as well. But let's add another page. And I want to continue around the loop. So I'm going to add the next piece of this. Hit OK. And you can see that I have the next piece of the loop here. And we're short on time. I'm just going to keep going. I'm going to add another page here and put in the rest of the loop. Okay. Hit OK. And here you can see I have the entire loop. Now, a real interesting part of using storytelling is that I can copy and paste from different pages. So what I'd like to be able to do is see what the effect of this new loop is going to do to the actual behavior of the model. So I'm going to go back to page 1. I'm going to click on the graph because I want a graph on that page. I'm going to click on, while holding down my shift key, reset the model, and I'm going to click on the run button, and I will copy those and go back down to this page. And I'll make this a little bit smaller. Whoops, don't want to move all that. So that you can see it. Okay, and I'm going to reset the model. But first I need to hit the experiment button, reset the model, and run it. Oh my, this didn't work. What happened? I was supposed to get some kind of a limitation here. I was looking for an S curve. So if I go back and look at my model, there's a very important piece of this that I forgot to put in, right? In order to calculate the natural deaths using the average lifespan, I also need to know how many prey there are. So there's a link here that's missing. So if you make a mistake on the page and double click on the page to this window and change visible structure option, I click on that and I can go back to my model and I can add that last loop, and let's put in the label for the balancing loop. Okay, and I come back here, and if I now go to the experiment mode of this, reset the model and run, you can see that we now have something that's limiting the population. I don't happen to like this very much because it doesn't look much like the original exponential growth curve that I had. And I might want to be explaining there is exponential growth. That's the dominant loop for a while, but we don't really see that in here. So another thing you can do is you can add some interactive pieces to this. Emre was kind of getting into a lot of this, but I'm going to put in a slider. And for that variable, let's say it's the initial value of the prey. Okay, and I click on that. And if I come back to the experimental mode here and I bring this down to a much smaller number and I run it, you can see I start to get my exponential. You can see the exponential part of that growth curve. Now, I'm running short on time. So I'm put in lots of text in here to explain, and maybe even one of these annotation buttons. That would be another instruction button that would say, play with the slider and see what you can find out. But let's just add one final page here. So for the last page, I want to add the entire model. I'm going to take out the initial predators and the initial prey, but I'm going to add that. Okay, on this page. Again, I can go back here. I can select the graph. I can select the run button. I can select the reset the model button. Copy those and then paste them on this page. We'll make this a little bit smaller so you can see it better. And on the prey graph, I'm going to add the predators. Okay, I can reset the model. And if I run it from, oops, I got to go back up to the experiment mode. Keep forgetting to do that. If I reset here and then run the model, you can see I get the oscillating behavior, but it's really hard to see the predators. So I'm going to double click on this and we're going to fix this a little bit. We want the predators not to be a dash dot. I think I want it to be solid. And I would like the graph to be a multi-scale graph. And the y-axis is comparable. And there you can see I have what I'm after. So I've almost finished this whole thing, right? Here's my first page of the model. I'm going to click on the space bar. You see it goes to the second page, third page, fourth page, fifth page, like that. What I need finally on this last page is a way to get me out of this, right? So I need to create one more button. And I'm going to call that button return to the home page. And I'll select an action here, which now to pay that I want. You can see I have options there, but I want to go to the home page like that. Okay, and if I come back to the experiment menu and I hit return to the home page, it will take me back to the home page. Now there's one thing missing, still one thing missing here. When I first open the interface window, this is what I get, right? And so I need a way to get to the story, right? So I'm going to add one last button here. I'm going to select the action of navigate to story. And we'll put here open story will be the label for the button. And I'll just put it right over here, right over the start here. So now, if I come back in here, I have my entire thing set up, right? This is my home page. I can hit open story. I can, I would want to reset the model before I save any of this, right? But sorry, let's go back to the home page here again. Return to the home page. So Here's my story, right? I can scroll through the pages, one page at a time. Of course, I would want to have some kind of description in there, or I would be at the front of the classroom and talking about this and asking students what they thought of the different pieces of the model. And then the last thing I'll just say, I know we're really short here, it's 1 o'clock already. If you wanted to publish this, go up here to the file menu and hit publish, and it will exchange, which I'm having trouble with. But anyway, you could publish the model from there. And I think I'll stop at this point and open it up for questions. So sorry, that was very quick. I know. I felt very pressed for time, so I'm sorry.
We will stay. And for those of you who have some time, we welcome you to stay. But we are open for questions now from anyone. This will be publicized on our webpage, on the System Dynamics Society pre-college webpage, so you can look at the recording later. Does anyone have any questions? If you could raise your hand, it would. I know many people have to leave. At least you got to see all three presentations. But if anyone has any questions for any of us, while we're waiting for someone to think up a question.
Well, I think Stefan,
Oh, wait, does someone have their hand up?
well, in
Oh,
the chat,
go ahead.
In the
Yes,
chat.
go ahead. Go ahead.
how much time and which tools do you use to create the lessons you showed? Well, it depends on the lesson, but the tool is always Stella Architect and some kind of an SVG editor. Anyone can do because any kind of SVG image is suitable to be used in Stella Architect. But time is very dependent the uh, on the topic because uh, which one? One of the my longest one is 21 weeks. It was menstruation cycle in biology, but it's about 8 weeks, I can say. I do a draft and then the teacher reviews it, makes some comments, gives feedback, and I redo that, and this goes on and on, probably a couple of months, each of them.
I would like to say that MRay is going to do a workshop in April to show you all or whoever wants to come how to do this. So that's what we have planned for April, is for MRay to go into more details about how you can actually do this in Stella Architect. Any other questions?
I guess we were so complete that everybody understands everything.
Well, and you do have a chance to look it over again. That's
Yeah.
the beauty of having this recorded, is that you can go back, you can watch it over and over again to get more detail um, as you want. Are there no other questions? No one in the chat. Please remember that we are having a big symposium, big for us. It's our first conference, K-12 pre-college systems thinking symposium on March 22nd. And we have been advertising that. So we hope, what kind of investment are required for schools to begin to use these tools? Well, for the for the loops that matter, it comes with all versions of Stella. So Stella Online, which is free for everyone. You go to the exchange.ic I'm sorry, exchange, is it dot?
Yeah.
Exchange.icsystems.com, and you make an account and you can get to Stella Online, which is what I showed in. But Stella Professional is a web-based modeling software that can be used but free. It's a site license that's free from IC Systems for all K-12 schools. But what Emre showed and what Steve showed are not in the free versions. They are only in Stella Architect or Stella Designer, and that has to be paid for. Now the schools can purchase a site license of Stella Architect. I think it's something like $1,300, but it could be on all the computers in the entire school. But that's a different situation. But you can have a teacher with one copy of Stella Architect can make an interface and publish it to the Exchange site for free, and then all the students can access it for free. So you have to have one copy of Stella Architect to create the special interface or the storytelling. But as Steve was trying to show at the end, you can publish it, that interface or storytelling, for free to the Exchange website and have all of your students access that particular interface or storytelling for free from the Exchange website. But you can't produce it in the free software. And one license of for a teacher or a K-12 person of Stella Architect, I think, is $250, I believe. Pretty close to that, one copy. Are there any other questions? Doesn't look like it. Okay. If you want to contact us, you use our email is pre-college education at systemdynamics.org. I think that's right, isn't it? Since I don't use it myself, I never have it. So pre-college education at systemdynamics.org. I think that's right. Ooh, did I do that wrong? Oh, I put a space. Sorry. There's no space between system and dynamics. That's why it didn't come out right. Sorry about that. So if you want to contact us, please do. We hope always to work with any people interested in trying to infuse system dynamics into K-12. And in Turkey, they're using stock flow, just one stock, one inflow, one outflow, just a diagram. I think starting in grade 1, Emery, where do you start the stock flow?
Stock flow in kindergarten.
Kindergarten, just the structure, just the picture. This is a tub and we're filling it and we're emptying it, but they do more than just water. They do a lot. They just do it with pictures and things like that, the ideas. So we can help you because we have experience clear from kindergarten through university on the use of system dynamics to help study dynamic feedback systems. They don't do feedback in the little grades, but they do, as soon as possible, talk about feedback. No one else? Okay, well, then I guess we're finished. And we hope you enjoyed the presentation. Remember the symposium next month, March 22nd is a Saturday, and it will be 5 hours, and we have some great presenters. And George Richardson will do the keynote, and he's terrific. He's just a marvelous speaker and a very well-known system dynamicist who has mentored many of us. We hope you will be with us. Thank you very much for coming.